Hey, sixth grade. This video is going to cover 1110 notes. We're going to do more work with triangles and specifically what's called angle-angle triangle similarity. So up here we have some notations that we've talked about in previous lessons. The congruent symbol, which means same exact shape, size, and measure. We saw in a recent video parallel lines. And then this similar notation. So similar is not the same thing as congruent. If two figures are similar, that means their angle measures do stay the same, but the size of their shape has changed. So they form some proportional relationships. That was in the first part of chapter 11. Okay, so here we have the angle-angle criterion. That's a fancy word for a rule. And what this rule says is if two angles of a triangle are congruent to the corresponding angles of another triangle, then the two triangles are similar. So essentially what that's saying is if we have two triangles here, and we say this is 80 degrees and this is 60 degrees, and then we have, even though this triangle is larger, 80 degrees and 60 degrees, if we know from yesterday's lesson that the angle measures have to add up to 180 degrees, that means these have to have the same exact angle measures. Okay, so even though this bottom triangle seems to be bigger, it is still similar because it has the same angle measures. Okay, so let's go ahead and try example 1, and if you're following along in your workbook, this is the try it on page 704. We want to state whether or not these two triangles are similar. Okay, so that's what that symbol is here, and we're going to explain our answer. So I showed quite a bit of work here, which you might find unnecessary, but again, like in the last video, we want to get as much practice with equations as we can, since that is a very important topic in pre-algebra. So here we have two triangles, triangle XYZ and LMN. And they give us two measures of the first triangle, two measures of the second triangle, but they're not the same. Angle Y and angle M are equal, but we want to see if some of these other angles are actually corresponding. So we have one pair of congruent angles, but we have to have two in order for us to say that these are similar. So to zoom in here on the first triangle, we know that this measure of angle X plus 92 plus 42 has to be 180 degrees when we add all three angles together. All right, so we have 134 degrees total accounted for. If we take that away from 180, that means this angle has to be 46 degrees. Okay. This second triangle here, we do the same approach. If we add all three angles together, 145 degrees is accounted for. If we take that away from 180 degrees, that means angle N has to be 35 degrees. Since these are not going to be equal to the angles that they're giving us, these are not going to be similar. There's only one pair of corresponding angles that are congruent. Before we start example 2, I'm actually going to go down to this note that I've added. Here we have two separate triangles, but notice that in this section right here, we call this X, but we can't call this angle X and this angle X because those are two separate angles. So we have to be a little bit more specific when we measure and name angles that have multiple angles involved. So when naming an angle that is adjacent to another angle and not simply a vertex, you have to use the 3 points for the name. The vertex has to be in the middle. So here's a simpler example. Here we have two angles that form a straight line, and let's say we want to focus on this obtuse angle. Okay, there's two ways we can name this. We can either name this angle RST or angle TSR. We can't just call it angle S because there's two angles formed here at this vertex. Okay, so that's going to come in play with example 2. One thing that might be simpler for you is to redraw this as two separate triangles. Okay, so that's what I'm doing off to the side here. So we've got Q, R, X, Y, Z. Okay, this is going to bring back some topics from angle relationship lessons. It's telling you and showing you in the diagram that these two lines are parallel, line QR and line YZ. So we want to now state if these two triangles that are formed are congruent. So I have some notes written off to the side here from 11.8, and it's color coded for you. I need to prove similarity. In order to do that, I need to prove that at least two angle measures are congruent to their corresponding measures. Okay, so here we have, I like to start with the orange here. Here we have a pair of vertical angles being formed, which means these orange angles have to be congruent. So from there, we already know that angle QXR and YXZ are congruent. Now we need to prove a second pair of corresponding angles being congruent. And with this, I went ahead and did all three, but once you found a second, you could have stopped. So now if I focus just on, I'm going to redraw this actually and do, it's not going to be very straight since I'm holding my phone in one hand. Okay, so I'm going to redraw this image without this line here. Okay, so I have two parallel lines. And if I focus on this and this, I have, oops, sorry, and this, these two angles here, I have alternate interior angles. Okay. If I focus on just this portion, which matches up right here with my purple angles, I'll put them side by side for you. Okay, so I redrew this, just focusing on where those purple angles are drawn. We have alternate interior angles, and we know from lesson 11.8 that that means that those angles are congruent. That's enough to prove congruence, because if two of the three angles of corresponding triangles are congruent, then the third has to be, but I went ahead and also included in the green another pair, that third pair. Okay, so in my explanation, I stated that all three were congruent. Again, you only had to state two, so as long as you had two of these three pairs, you are good with your answer. Okay, so those are two ways that you can prove similarity. The first example, if they give you angle measures. The second example, using angle relationships. Okay, example 3, we have a couple different approaches that we can take here. This is from the try it on page, the bottom of page 705. We want to find the value of x if the two triangles are similar and explain how we found those values. So here, zooming in, I added some work. And what they're giving us is in the pencil. So here we have these two triangles. They're actually formed by two lines crossing, and this symbol here means that this is forming a right angle or 90 degrees. And we have a pair of vertex angles that are created here. So if this is a right angle, then this vertical angle also has to be a right angle. Okay, this tells us that these two angles are identical. Okay, and then it tells us that this over here is 15x. If we are being told that these are similar, then that means if these two angles are equal and this is similar, then these three angles all have to be 15x. Well, if these are all three 15x, then the fourth one also has to be 15x. Okay. So I showed some work here and some explanations. The symbols for the smaller triangle show that that one angle equals 90 degrees and the other two are equal. Well, if there's a total of 180 degrees in a triangle, then that means these other two remaining angles, 180 minus 90, we have 90 degrees left over, divided amongst the two equal angles. That means these have to both be 45 degrees. And if these are 45 degrees and this triangle is similar, so these have to be 45 degrees, then that means 15x has to be 45. Okay, so that's what I have here. So x would end up equaling 3. Since the vertical angles are congruent, the angle is 90 degrees. The remaining angles are corresponding angles and therefore congruent. So each of those angle measures 15x degrees or 45 degrees. If 15x equals 45, we divide, the value of x has to be 3. Okay, an alternate approach you could have taken was we could have said, well, if we know that these have to be identical, since the triangles are similar, if these are identical, then these have to be identical. Then we can use the 90-degree angle plus both the 15x degree angles has to equal a total of 180 degrees. And we can solve that way as well. Subtract 90, divide by 30, and we get x equals 3. Okay, so those are two different ways that you can approach this problem. Or there might even be an alternate approach that you took. But any way you take to solve this problem, you have to make the connection that if these triangles are similar and these two angles are the same or congruent, then these two angles also have to be congruent. And from there, you can show your work to get to your answer. And that, ladies and gentlemen, wraps up 1110 notes. If you have any other questions, make sure you email me or send me a Google Classroom comment.